Hello everyone, and welcome to another math tutorial. This video is on perimeter and area in a coordinate plane. In this video, besides finding perimeter and area, we're also going to talk about how we name polygons, how we can classify polygons as well. And then in addition to that, we'll see hopefully some familiar content on perimeter and area. Okay, so when we talk about polygons, what we're talking about is a closed plane figure formed by three or more sides. What we mean by closed is that there's no gap, there's no opening, right? So if I were to draw a figure like this, that's not closed, okay? So we need to have a closed plane figure formed by three or more sides, right? So here's a picture of a polygon. Now, polygons are made up of vertices. Right? The vertices, or singular vertex, are just simply the points that make up the polygon. The segments between the two vertices, or any pair of vertices, are just simply called the sides. So the sides are segments. And then when we name a polygon, we simply name it by listing all the vertices. Okay? And you have to list the vertices in consecutive order. So this particular polygon has 5 vertices, so we just simply name it polygon, and you can go in either direction, but here it's polygon A, B, C, D, E, so A to B to C to D to E. You can start at any point, and you just need to go around the polygon in one direction, listing out every single point. Now this particular slide has some information on it that I no doubt believe that you're aware of, you've at least heard as you've gone through your grade levels up to this geometry course. But polygons can be classified by their number of sides. And like these names, no doubt you've heard some of them. Like I'm sure everybody knows what a triangle is. Triangle, if I asked you to draw a triangle, right, we'd all just draw something like that. All right, we know what these shapes are going to look like. What you need to know are the names of these, okay? So there's not really much that I need to write on this slide. It's just something that I think you should hit pause, take a moment to read through these. The ones that you don't know, maybe make note of that, maybe jot them down in your notes, work on memorizing the names of these different polygons and how many sides polygons have. Now, one note here, the bottom line in this table, there are names for polygons beyond 12 sides. Nobody needs to really memorize those names. If you needed it, you could certainly just look it up. So if there's a polygon that has more than 12 sides, let's say we have a polygon with 20 sides, we would just simply call it a 20gon. So you can do that kind of naming system for anything larger than 12. Now, all polygons are going to fall into one of two categories. They're either going to be what we call convex or concave. So I want to look at this polygon here. I'm going to trace it out, and then we'll look at the definition here. So here's the actual polygon. It's a 4-sided polygon, so this is a quadrilateral. And a convex polygon, which is what I just traced out right here. The definition of convex is that no sides, okay, so none of the sides of the polygon, when extended, are going to pass through the interior of the polygon, okay? So you see that with the red lines already. So like this side right here, if I take this side and extend it here and here, notice it didn't pass through the inside, okay? It stayed on the outside of the figure. Well, all the sides when extended don't pass through the inside. And because of that, that makes it convex. Now, on the other hand, a concave polygon, right? So let's take, I'm not going to trace the whole thing, but let's look at this side right there. Well, if I take that side and I extend it here and here, notice that it does pass through the interior of that polygon. And because the extended side passes through, we can't classify it as convex, but we're going to classify it as concave. Okay, I kind of think of this as like if the shape like caves in on itself, that's a concave polygon. Okay, so let's look at an example where we practice classifying the difference between these two. Okay, the directions on this slide ask us to classify each polygon by its number of sides. Okay, so that's the chart from a few slides ago. And then tell whether it is convex or concave. Okay, so two things we're trying to do here. What's its name by how many sides it has, and then is it convex or concave? So let's start on this first one on the left. Let's just count the sides. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 sides in this polygon. If it's 8 sides, then we have an octagon. Now, this side right here of this octagon, when extended, notice it passes through the inside. That means this is a concave octagon. Now, our other example to the right, let's name it first by its number of sides. I'm going to number them just to make sure I don't miss any. Sometimes when you count, once you get around to the end, you might find that you've forgotten where you started. So I find numbering them is pretty easy to prevent that from happening. But I have 12 sides. 12 sides is a dodecagon. And notice that any of these sides that I pick, like this one right here, doesn't pass inside, right? This one over here doesn't pass inside. None of the lines extended are going to pass inside. Makes that convex. Okay, now we're going to do something that should be familiar to hopefully everybody watching this video. If you've made it to a point in your life where you're taking a course in geometry, you've no doubt had some geometry lessons kind of along the way in your other math classes. And one of the things you're definitely going to see along the way is perimeter and area formulas. And so we're just going to do a few shapes in this particular lesson today. Throughout the course, we do a lot more of this kind of later on. But for now, just triangles, squares, and rectangles is what we're going to look at. It's what we're going to see in the assignment for this lesson. So first of all, remember that perimeter is just simply the distance around the shape. Okay, you really don't need formulas for that, because all you're doing, like right here, all you're doing is adding 3 sides together. Or here in the square, you're adding s plus s plus s plus s, or 4 times s, right? Or here you're adding length and length and width and width. You can work them as formulas, but really it's just add all the sides up. That's perimeter. Area is a little bit trickier, and we do have some formulas, so I do recommend that you memorize these formulas. And we'll do examples that are going to show these as well. But again, you've certainly seen these, so we're just kind of reviewing this. Area of a triangle is half its base times its height. Area of a square is its side times side, or side squared. And area of a rectangle is its length times its width, which is kind of like square. It's also side times side, but the sides can be different. So length and width. Sometimes people do base and height of rectangles as well. As long as we kind of know the idea how to do it, you can memorize the formulas if you want. All right, let's look at some example problems. Okay, find the perimeter and area of the triangle formed by the 3 points. So let's plot it out first. So point X is at 2, 4. Point Y is at 0, negative 2. And Z is at 2, negative 2. So I've got this triangle right there. Now, as far as perimeter goes, I need to find all the links. I'm just going to count this out, at least the ones that I can. YZ is 2, XZ is 1, 2, 3, 4, 5, 6. To find the perimeter, I'm going to have to know the length of this side right here. So this is like a distance problem. What's the distance between points X and Y? I can find the difference or the distance by doing Pythagorean's theorem. I can do 2 squared plus 6 squared equals c squared. So I got 4 plus 36 equals c squared, which is 40 equals c squared. So c is the square root of 40. And the square root of 40, let me get my calculator out. The square root of 40 is about 6.3. So that's the length right here. So our perimeter then, let's do P for perimeter, is going to be 2 plus 6 plus 6.3. Perimeter looks to be 14.3. I'm just going to put units. Okay. Hopefully we can see that on the video. Okay, next let's do area. Now for this particular triangle, area is going to be much easier to find, much less work. Area of a triangle is half times its base times its height. Now this triangle that we have is a right triangle. The base and the height are the measurements where the right angle meets. So in any order, half times 2 times 6. 2 times 6 is 12, and half of 12 is 6. Because this is area, we want the units to be squared. Okay, this next problem, I have another triangle. So if you want, you can certainly pause this, work it on your own, and then press play to check your work. But I'm going to go ahead and get started on it right now. You can take notes on it if you want, or like I said, just try and work it yourself to see if you've got it down. So the triangle is at -3, 2, point G, 2, 2, point H, -1, -3, point J, and so like this. All right, so perimeter, I need the lengths of all the sides. Now GH right here is the easy one. I can just count that out. That's 5 units. To find GJ, however, I'm gonna have to do Pythagorean's theorem. So let's see, to get from G to J, I'm going down 5. I'm going over 2. So this is gonna be 5 squared plus 2 squared, that's 25, and 4, which is 29. So I want the square root of that, and the square root of 29 is about 5.4. And over here, for HJ, I'll do the same thing. From H to J, it's down 5, but it's over 1, 2, 3. So that's 25 and 9, so that's 34. I want the square root of that 34, which is about 5.8. So the perimeter then is going to be 5 plus 5.4 plus 5.8. So I get 16.2 units. Now to find the area. For area, I need to do, again, the formula is half times base times height. Remember, the base and the height meet at a 90-degree angle, right? And so if I look at all these angles, none of those are right angles. I know what right angles are, even though we haven't talked really about angles yet. I know what 90 degrees looks like. So I have to create a 90-degree angle. I can come straight up from point J to that segment and make a 90-degree angle. And that is 1, 2, 3, 4, 5. So my base and my height are these two segments, and they're 5 and 5. So my area is half 5 times 5. 5 times 5 is 25, and half of 25 is 12.5. Area has square units. Okay, next one, we're going to find the perimeter and area of the rectangle formed by the 4 points. So let's plot this out to begin. F is at -2, 3. G is at 1, 3. I is at 1, -1, H is at 1, -1. And J is at -2, -1. So here's 4 points that are the vertices of a rectangle. Okay, so let's start with perimeter. Perimeter is the distance around. So from F to G is 3, G to H is 4, J to H is also 3, this is also 4. So the perimeter is going to be 3 plus 4 plus 3 plus 4, which is 14 units. The area can be done two different ways. You could just count how many squares are inside that rectangle, certainly. Or you can do the length times the width. The length times the width are the two different dimensions there. So the area is going to be 3 times 4, which is 12 units squared. Okay, we have one final example. The directions say on your own, so you can certainly pause this and work it out on your own if you would like, and then unpause it to see what the answer is at the end, or you can follow along. I'll leave that up to you. But we want to find the perimeter. It's just perimeter of the polygon formed by the vertices. So let's begin by plotting this out. So we've got a point at -1, 1. Got a point at 4, 1. Let's go ahead and label these two. That's K, that's L. Got a point at 2, -2. That's M. We have a point at -3, -2. That is N. Okay, so to find the perimeter, I need the lengths of all 4 sides. I'm going to start with the easy ones. From K to L, I can count. That's 3. From M to N, 1, 2, 3, 4, 5. Okay, those are the easy ones. Now for the other two, for ML, I'm going to have to see this as a triangle, which is 2 by 3. So the length of ML is going to be the square root of 2 squared plus 3 squared. That's coming straight from Pythagorean's theorem. So ML is the square root of 4 and 9, which is 13. The square root of 13, we've seen that already in a separate problem. The square root of 13 is about 3.6. I need to do the same thing for Kn. So Kn, that triangle is 1, 2, 3, 4, and 1, 2, 3. So Kn from Pythagorean's theorem is the square root of 3 squared plus 4 squared. That's 9 and 16, which is 25, which is 5. Okay, so our 4 sides are 5, 5, 3, and 3.6. So the perimeter is 5 plus 5 plus 3 plus 3.6, which makes our perimeter 16.6 units. Okay, that concludes our video on perimeter and area and a coordinate plane. If you have any comments or questions, please feel free to leave them down below. As always, if you found this video helpful, please support the channel by giving it a thumbs up. I'd like to thank you for spending your time with me and watching this video. I'll see you in the next one.